The apply function is a vectorized function in R that applies a function to a margin, which really just means dimension, of a data frame, matrix, or array. The primary arguments of the apply function are capital X, which is a data frame, matrix, or array, the margin, which is a vector indicating the dimension to apply the function to. Providing a 1 indicates rows, 2 indicates columns, 3 indicates the third dimension of an array, 1:2 indicates the row and columns of a three-dimensional array, etc. The next argument is capital FUN, fun, which is the function to be applied to the margins or dimensions of X. And then we have the ellipsis argument, ... which allows you to provide additional arguments that need to be passed to the function we gave in fun. So for example, there may be some other parameters, some other arguments in fun that we need to specify, and we do those through the ellipsis argument. Lastly, there is a simplify argument, which is a logical value indicating whether the results should be simplified if possible. The default is true, and I recommend you leave that on. So we're going to provide several examples using the apply function below. We'll start off by creating a very simple matrix. We're simply going to bind together the column that has the values 1 through 5 and the column that has the values 6 through 10. And we assign that the name mat. And the first example of the apply function here is we are going to apply to mat along the margin equal 1, which is the rows. We're going to apply the function mean. So basically what we want to do here is we want to apply the mean function to each row of mat. So we do that, and you can see that we get 3.5, 4.5, 5.5, 6.5, and 7.5. And if we look at the values in our matrix up above and we mentally compute the mean, we see that we do get the mean of the first row, of the second row, the third row, the fourth row, and the fifth row. So this does give us what we expect to get. Alternatively, we could specify the margin to be 2, in which case we would apply the mean function to each column of mat. And if we do that, we get 3 and 8, because 3 is going to be the mean of the values in the first column of mat, and 8 is going to be the mean of the values in the second column of mat. Note that there are vectorized functions, row means and col means, which could have produced the same results and actually with simpler code. But I wanted to show you a simple, straightforward example of the apply function, and the previous example served that purpose. Let's do some examples where we consider how to use the apply function on a three-dimensional array. So we're going to create a three-dimensional array with dimension 3 by 2 by 4 below. And so you can see that we have 4 elements in the third dimension. Basically, each one of the elements of the third dimension is a 3 by 2 matrix with different values for each one of these matrices. That will make it easy to distinguish results that we're going to get from the apply function. Let's compute means for each row of A. So we're going to apply the mean function to each row of A. And what do we get? We get 11.5, 12.5, and 13.5. So where are those numbers coming from? So in fact, we are averaging all of the values in the first row of A across all columns and the third dimension. So what's going on here? We are calculating the mean of 1, 4, 7, 10, 13, 16, 19, and 22. All those observations are in the first row for at least one column or dimension of our array A. And so if we compute the average of those values, we get 11.5. More simply, the application of the apply function that we just computed is equivalent to computing the mean of A and selecting the first row of A. Similarly, the 12.5 and the 13.5 come from averaging all the observations in the second row of A, and then for that third element, for all of the observations in the third row of A. Now let's compute sums across the third dimension of A. So I'm going to apply the sum function along the third dimension of our array A. And when I do that, I get 21, 57, 93, and 129. 21 comes from adding all the values in the first element of the third dimension of A. So more specifically, it's going to be equivalent to running the following command. So if we take the first element of the third dimension of A, and then we add all the values, that we get from extracting those elements, we get the value 21. And so that's equivalent to simply adding up all these values here. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 is going to give you 21. Similarly, the 57 is going to come from adding up all of the values in the second element of the third dimension of A. The 93 comes from adding up all the elements in the third element of the third position of A, etc. I previously mentioned that we can actually put multiple margins here in the margins argument of the apply function. So what if we computed the mean across the first and second margins of the array A? Then we get 10, 13, 11, 14, 12, and 15. So what exactly is going on? So what's actually happening is that for each element in the first and second dimensions of A, we're drilling down and computing the mean across the third dimension. So we're going to get 1 plus 7 plus 13 plus 19, which is going to be 40, divided by 4, which gives us 10. Similarly, if we are looking at row 2, column 1, and we compute the mean of all the values across the third dimension, we get 2 plus 8 plus 14 plus 20, which is 44, divided by 4, which is going to give you 11. The math works the same way for the other elements of A. Drilling down into some of the details there, the 10 comes from averaging the values A111, A112, A113, A114, which is 1 plus 7 plus 13 plus 19, divided by 4, which is equal to 10. Alternatively, it's equivalent to running the following command. We subset the values in the first row and first column of A. We compute the mean of those elements, and once again, we get 10. So you can see that when we start using the apply function on arrays, things start getting a little more complicated, and you really have to be aware of what's happening to make sure you understand what you're getting and how to use it.